Assalamu alaikum wa rahmatullahi wa barakatuhu. Good morning to all of you. In the last session, we were discussing regarding the food web. This is the continuity of this lesson. And today we are going to speak about the nutritional behaviors of organisms in the ecosystem. From lower grades onwards, you know that there are three types of nutritional behaviors. One it is autotrophs, the one is heterotrophs, the one is decomposers. Autotrophs, they are organisms who can transform simple inorganic compounds, into organic compounds to fulfill their nutritional requirement. So, from the grade 6 onwards, you have studied producers. Plants can make their own food. They are called autotroph. Okay, so that's the idea. So simple inorganic compounds are converted to organic compounds. Right? These autotrophs we can divide it into two. One we call photoautotrophs, other one is chemoautotrophs. Photoautotrophs and chemoautotrophs both convert inorganic compounds to organic compounds. That's why they are called by the name autotrophs. In this case, what type of energy they use? According to that one, we divide the autotrophs. Photoautotrophs use light energy. Chemoautotrophs use chemical energy. Chemoautotroph nature can be seen only in some bacteria. We cannot find it in higher plants. Some bacteria only do chemoautotrophic nutrition. So that is regarding the autotrophs. Heterotrophs mean mainly it refers to organisms who depend on the autotrophic organisms directly or indirectly. Okay, mainly in the environment, heterotrophs are animals. They can't make their own food. So they depend on other organisms for their nutritional requirement. These animals, these heterotrophic organisms are also called consumers. Heterotrophs or the consumers can be divided into several levels. Primary consumer, they are the herbivores who are directly feeding on the producers. Secondary consumers, they can be carnivores or omnivores, they feed on the primary consumers. Tertiary consumers, they are mostly carnivores, they feed on the secondary consumers. Like this, the animals can be classified. Thirdly, we speak about the decomposers. In the case of decomposers, they do the work of breaking complex organic compounds into simple compounds. Complex organic compounds into simple compounds. After organisms die, after we bury the body of the organisms, the complex organic compounds in their body are converted to simple organic compounds or the simple compounds can be organic, the simple compounds can be inorganic. That is not a matter. According to syllabus, complex organic compounds are converted into simple compounds. Okay, decomposers are also called saprophytes because they are living or consuming or they depend on the dead material. They are also called by the name saprophytes. Decomposers can be either bacteria or fungi. Either bacteria or fungi. Decomposers can be either bacteria or fungi. Right? And thereafter, we come for ecological pyramids. In the case of ecological pyramids, okay, I can just show you, this is an ecological pyramid. It is a pyramid called number pyramid. It's a graph actually, right? This is an ecological pyramid. So it's called biomass pyramid. And there is another pyramid, energy pyramid. So ecological pyramids are graphs. We are drawing graphs based on number, based on biomass, based on energy in each trophic level. Okay, in each trophic level. What you have to do is collecting an area. If you are doing the number pyramid, in each trophic level, trophic level, all the producers are coming to the first trophic level. All the consumers, primary consumers are coming to the second trophic level. Last class I told you that. Like that, we are counting. So counting is not easy. Okay, small plants you have to consider, large plants you have to consider, even very small plants you have to consider. It's not easy, so it's not simple. So um, theoretically it is easy, practically it's very difficult. Even all three pyramids are very difficult to construct. There is only a hypothetical one at the moment for you, right? So in the ecological pyramids, as I showed you, in the bottom will be taken by the producers. The second level will be taken by the primary consumers. Next one will become the secondary consumers, tertiary consumers. It will construct up. It will be constructed up. Okay. Ecological pyramids are divided into three types. As I showed you, they are pyramid of number, pyramid of biomass, pyramid of energy, or number pyramid, biomass pyramid, energy pyramid. Okay. Here, first of all, we discuss about the number pyramid. So number pyramid, how do we construct? It is the graphical representation of number of organisms in different trophic levels. Every trophic level, how many organisms are there? So what you have to do is you have to say you want to do it, you go to a jungle. In the jungle, or you have to go to a place. In that place, how many producers are there? How many primary consumers are there? How many secondary consumers are there? You have to calculate. And further, you have to calculate the area of that. And you have to find out as an average how many organisms are there in every square meter that you have to do for the producer, that you have to do for the consumers, one by one you have to do. Right? And you have to construct. You have to construct. Now, length, horizontal length is the representation. Horizontal length is the representation. More and more organisms horizontally, it will be becoming more longer. It's not the height, it is the length. Horizontal length is the representation. Okay. This is the representation. This will be showing the distance. So in the second one, this is the representation. The 200 is this length. This length. If 300, it will go longer. Okay, like that. So that is number pyramid. In the number pyramid, according to your syllabus, two types of pyramids can be there. Upright pyramid. That means bottom more animals, more organisms, then little less, then little less, then with further less. It is constructed like a normal pyramidal shape. Another choice it is inverted pyramid. In inverted pyramid, you can see in the bottom few organisms are there. Compared to producer, primary consumers are more. Compared to primary consumer, secondary consumers are more. This kind of pyramids can occur. They are called inverted pyramids. Generally, inverted pyramids will come when there are parasites, when there are pests. When there are parasites, when there are pests. inverted pyramids will come. Okay, right. So number pyramids are two types. Inverted pyramids are there, upright pyramids are there. You have to draw these pyramids. No need to draw those pictures, but you have to draw the pyramids. Okay. Thereafter, you come to the heading biomass pyramid. Biomass means it is the amount of organic matter present. How to get it? Now, if you want to get the biomass, there is a drying method. In the drying method, you have to dry it. There's a special oven for that. Now, if you want to find the biomass of a plant, you have to cut that plant into pieces and put it in the dryer. You have to dry it. When you dry it, all the water will go out. What is the remaining mass? That's what we have to find. And that is going to be the dry mass. That is going to be the biomass. So we are representing the organic matter in each trophic level. In each trophic level, the organic matter is represented. Right? The biomass, dry mass is represented. It is measured in the unit of grams per square meter per year. Okay, normally biomass pyramids are upright, but in aquatic environment, especially in the ocean, there are possibilities to have inverted biomass pyramids. Inverted pyramids also possible, very rare, but possible. Okay, now if you consider this inverted pyramid, although coconut tree are small in number, mass-wise, coconut tree will be greater. So if you draw the biomass pyramid of this, coconut trees biomass will be bigger, then coconut beetles biomass, then insect parasites biomass. So for this particular number pyramid, biomass pyramid will be an upright pyramid. Okay, so biomass pyramid can be inverted sometimes in the oceans, aquatic environment. Okay, here also, you, as I told you, you don't need to draw the pictures. You have to draw this pyramid. And 12,000, what is that 12,000? 12,000 grams per square meter per year. 2,600 grams per square meter per year. Biomass calculation. And finally, you are coming to energy pyramid. It is the graphical representation that shows the amount of energy flow through different trophic levels. In that case, what is the unit of measurement of this? Kilojoules per square meter per year. Kilojoules per square meter per year. When you take the energy pyramid will be always an upright pyramid. There's no any chance for an energy pyramid to be an inverted pyramid. Reason, from one trophic level to another trophic level, when energy flows, 90% energy got lost. Right? Here in the first trophic level, there is 10,000. In the second trophic level, it is 1,000 mean. Here, 9,000 lost. 9,000 joules lost. That means 90% lost. Understood? Similarly, here 1,000 to 100 mean 900 joule lost. That means 90% of 1,000 lost. Here, 90 joule lost. So from one trophic level to another trophic level, all the time 90% lost is there. So because of that one, an energy pyramid is always it is an upright pyramid. There's no any chance for an energy pyramid to become what do you say, inverted pyramid. Okay, my children, so I am finishing the discussion with this. I have gone up to page number 7. Inshallah, with another video, I will again meet you. Complete the notes, complete the works, be ready. Okay, good night. Sorry, goodbye.